Hi, I'm Lorenzo and I'm a developer at ObjectBox. ObjectBox, for those who don't know, is a non-device NoSQL database, and with this release we present the vector search feature. The vector search feature is the task of searching for points in space that are near to a certain query point. Vector search finds application in many tasks, mostly in the AI field. One example could be, for example, retrieval, augmented generation, but in general, all those AI tasks that require a retrieval step. And with this release, we present the vector search feature in many APIs, the Python API, Java, Dart, and C. In this video, I will focus on Python because Python is one of the main languages used by the machine learning and deep learning community. The purpose of this small example is just to show how to use ObjectBox to perform a vector search. And for this example, we will use the capitals dataset. The latitude and the longitude will be gathered together in order to form the location, which is the vector on which we will search. We just have to load the capitals.json file. For this purpose, I have prepared an utility, which is the load capitals method. And I have also prepared an utility to visualize a subset of the capitals. So let's see what is the output. So in our case, we just have one object type, which is the capital. Every object must have an ID field. Then the name. Okay, we have to import those types. Okay. Then, since we want to perform a vector search on such location property, we have to define an index. Specifically, it's an HNSW index because it uses the HNSW algorithm. We have to decorate the class with the entity decorator. We have not finished. We also have to assign ID and UIDs to every entity, property, and index. This is something that is commonly hidden to the user in other languages, but the Python API is still in one of its early releases. Therefore, the user have to manually specify them. And the way you create the schema with ObjectBox is by defining the model. Okay, now that we have the model, we can create the actual store. By doing so, you are opening the database. You have to specify the model, which is the schema, and the directory of the database, which we will call, for example, capitals.db. Okay, now what we want to do is to insert the capitals that we have just loaded inside of the database. So we can create the box in this way, capital. Okay. And then we iterate over all the capitals that we have just loaded here. And we create the actual capital object, which is an instance of this entity class. So we specify the name. Okay, data in this case will be a Python dictionary. So here we would have to retrieve the name and the location that we set to be the latitude and the longitude. Okay. Now what we do is we insert the capital inside of the database through the put method. Now let's check that the objects were actually inserted inside of the database. To do so, we just print the objects count. So by doing so here we would expect to get 213 entries in the database. And we can see we have 213 entries. Okay, now we want to query, we want to perform a vector search, so to search the capitals that are nearest to a search in query point. For example, at 55, 0 and 0.0. And then I will call the same utility as before to visualize the query location. As you can see, the query point is the red dot here. And as you can see, visually, the nearest capitals should be London. This is the nearest, then Amsterdam. Now we can perform the vector search. So we have to get the location property from the entity. So capital get property, location, and then through the box we create the query to perform the nearest neighbor search. So query location property nearest neighbor query location. Then here we specify the number of nearest neighbors that we want to return, for example 5, and then we build the query object. Oops. Okay. Now we can retrieve the results by issuing find with scores. We can print the results, okay, maybe along with a ranking. Okay. Capital. Oops, not data. Okay. Capital score result. Capital.name score score. So we can try to run it. Let's delete the D first. Okay. And we can see that we got London, Amsterdam, Brussels, and then St. Peter Port and St. Helier. Okay, as a last thing, I would like to point you to the ANN vector search documentation page. Basically, it gives you more details about what is vector search, also some hint regarding how does it work. We still have the capitals examples. Here it's called cities, but it's still the capitals example. And you can look eventually at the code, or you could try the command line to test some to play with the vector search.